Alright guys, I decided to record this video again to show you basically the overview of the performance task, okay? So here's the performance task. First of all, checkpoint 1, if you check the calendar, for A Day will be due on the 17th and B Day will be due this Wednesday on the 18th at the beginning of class, okay? So please be ready to turn this in because I will not accept it late. Choose 2 items from the cafeteria. 2 items from our cafeteria, okay? First of all, let me read the introduction. You have been hired as the PISD district nutritionist, and you're analyzing the nutritional value of items served in the PHS cafeteria. You're concerned about your health and nutrition, so you want to make sure that the meals and snacks that students choose meet certain nutritional criteria while minimizing their cost, okay? Whoops. So it's all about what we're doing with these linear programming functions of minimizing or maximizing certain functions, if you will. So it's checkpoint number 1. Again, I just stated the due dates and whatnot. You need to choose 2 items from the cafeteria and acquire the nutritional facts labels digital copy from online. So there is one online, and I'll show you how to get that here in just a bit. And document the cost per serving for each of your items. Okay, so document the cost per serving of each of your items. Okay, so a serving is like when you sit down and you eat one meal. Okay, so that's one serving. Like if I ate a meal, and let's say that I had a burger, if you will. Okay, so that's my makeshift burger, and you have fries. Okay, so yeah, that's my makeshift fries. And then let's say that I had a drink, okay? So this right here is one serving. So if I have my burger here, that's one serving. And let's say that I had 5 meals in a day, then I would eat 5 burgers, okay? So this is a cost per serving. So this is one serving of a burger, this is one serving of fries, and this is one serving of a drink. So this whole meal, if you had it 5 times throughout the day, you could have 5 servings of each per se. So you need to record your items below and assigning a variable to each item. So whatever the first food item that you decide, assign it a variable. Whatever the second one is, we're going to assign it a different variable. This is the serving size that I'm talking about for each one. And this is the cost per serving, okay? So while constraints based on 2 different nutritional facts, from the left nutrient column on back, and an example could be like protein or fat. We're going to use the nutritional facts based on 1 serving of each item. Okay, so like I was saying, 1 serving of each item. So an example, minimum amount of protein or maximum amount of fat. Okay, so your constraints must be based on the real-world context of the problem. So we're going to divide, this is why it's highlighted or bolded, divide by the daily amounts by 5, because we're assuming each student will eat 5 meals in a day. 3 meals and 2 snacks per day to arrive at your constraints for your snack. So we're trying to say dividing by 5 because again, we think on average you're going to eat 5 times or 5 meals per se in a day. So divide the daily amounts by 5. Okay. And you'll see this on the labels, guys, whenever you read the labels and whatnot. So here's an example here. So the example is the nutritional item I could choose is fiber. Okay? And the justification could be strawberries have 3.3 grams of fiber per serving, whereas chocolate cake, and notice I'm using S for strawberries and C for chocolate cake, has 2 grams per serving. Using the nutritional or nutrition guide and dividing total daily allowances, so total daily allowance, those numbers that they show on those labels, we're going to divide by 5 because of the 5 meals that we're talking about earlier. We want between 5.2 grams and 5.8 grams of fiber for a female. So 5.2 and 5.8. And this is how you get the 5.8 and 5.2. And this is how we build our inequalities. Okay, so these are the constraints for the inequalities, similar to the word problems that we worked out in class. All right, so let's look at some examples. Right here you see, let me go back up, this 5.2 and this 5.8. So for females, we're showing, let me go right there, the fiber for females is going to be between 5.2 to 5.8. And this is what we get from this next screen right here. So we go to fiber, we go to females, and you can see, so females, we go to fiber, we can divide basically these pieces by 5. Okay, so we see 26 divided by 5, and we see 29 divided by 5. This is how we would get this, and this is how we would get that one right there. Okay, so that's just an example from these labels that I was talking about of how these are daily values, so in a day, and since we're assuming that you'll eat 5 meals in a day, this is going to be per serving. So for each time that you have one serving or one meal per se, you're having 5.2 grams to about 5.8 grams of fiber. Okay. All right. So now you can find this form or these labels also. They're compiled from www.netwellness.org, or this other one that you can click on, and you can do direct links from this if you're accessing these from the calendar in Google Classroom. Whoops. Ooh, I'm not sure why that one is not working, so maybe not on that one, but you can do from the other one right here. Okay, and then you can get the information that you're needing if you need to go there through the link. All right, so that's checkpoint 1. Again, read them carefully, print them off at home, and be ready to turn this in on the appropriate due dates. Checkpoint 2. Do this Thursday or Friday, depending on if you're in A day or B day class. And at the beginning of class, you're going to turn in a hand-drawn, not Desmos, these are hand-drawn graphs, and solve constraints with all steps shown on the back. So it's okay to use Desmos on the final project, but we want you to hand draw these and show all that work on the back. Okay? Alright, so using the cost per serving of each item, write an objective function to minimize total cost. So we're trying to minimize total cost, and we have to come up with our objective function that we're working with today in class right here that we're trying to maximize or minimize. Solve all 4 of your constraints for one of your variables. Whatever you solve for, that's your vertical axis, and show that work on the back of this page. So graph your constraints on the graph provided below, label your axes, and heads up, if your feasible region ends up completely outside of this first quadrant, then you must adjust one or both of your constraints. Like pick a different nutrient, or you can even change the scale of the graph if you want. And Desmos.com is an excellent graphing tool to help you. Okay, so you can see from that what your scale is going to be on the X and Y axis. Because right here, like this is the Y axis, this is the X axis. So we're only talking in the upper right hand corner, like basically of a normal graph. We're talking about drawing all that right here. Okay? And then solve your constraints for one of your variables. This is where all the work would go on the back. Then you come over here to checkpoint 3. Due next Wednesday or Thursday, depending on what day you have, at the beginning of class. List all of your critical points. Remember, these are the corners or the vertices of your region. You're going to round to the nearest thousandth, so it's like whatever that third decimal is, you're going to round to it or truncate. So let's say you had like 1.5. You could round this to 0.002, or you can truncate it and just chop it off at the third decimal and be done. So rounding versus truncating. Okay. Use your objective function. Calculate the cost for each critical point. So basically, remember how we were doing the P's and we were trying to maximize these P's today in class, and we got it from 4 points, okay? And then whenever we actually plugged them in, we could see how much were we getting on each one of these to see which one would be the maximum or the minimum, okay? And that's what we're doing right there in step 2. And in step 3, what combination of servings do your 2 snacks from number 2 above would minimize? So in other words, which ones would minimize the cost of the student? And is this reasonable? Justify with complete sentences. Number 4. So from a cost and health perspective, should you recommend this snack to the district? Why or why not? From both perspectives. And you have your justifiable work to basically support your answers, whatever you decide. Justify your answer with the calculations throughout this project. Okay? So this is a huge, huge linear programming project because it's connecting real-world data with real-world justification on something that kind of you're affected by every single day. I mean, looking at these nutritional values and whatnot. So the rubric is this. You obviously want to get all these points if you can to get your highest score on this performance task. So let's say that you're missing both labels. Well, for this checkpoint 1 section right here, you would get 0 points. Okay? So all of checkpoint 1 that is due basically next class are these checkpoints all right here. Okay, so please read the rubric carefully to ensure that you are maximizing anyway, so that you're trying to maximize your score. Get it? Maximizing and linear programming. Anyway, and then checkpoint 2, those are your the rubric for as far as how many points you're going to be able to get whenever you turn in checkpoint 2. Okay, so please, please, please read the rubric. Be very precise with your work. Very neat. I will present these for sure. And you can even tell that there's 10 points from neatness right here. Ultimately, whenever you turn this in, well-organized type uses titles professional quality. Okay? And the last thing, the final project. So on a standard half poster board, so not a full poster board, a half poster board. Please, please, please do not give me a full poster board. I'll ask you to do it again. You must attach your nutrient labels and the final draft of everything you have already turned in, but this does not mean you're going to cut out the original checkpoints and then just glue them to your poster. Okay, so the expectation is that your explanations and answers to the questions will be typed, printed, and glued neatly to your poster in a very organized manner. Okay, again, take a lot of pride in your own work. I will be displaying and I will take pride in your work as well. So it is acceptable that the computations are handwritten. Or if you want to choose to present your final project digitally using Google Slides and submit via Google Classroom, that's okay. You just got to make sure that you contact me early and you let me know that it doesn't change your due dates. Your due dates are still the same as far as what they were listed as going through the project. So okay, so the final project, whatever that final due date is, I do expect to have it basically already turned in through Google Classroom should you decide to go through this Google Slides route.